Alright, today's objective, cube and cube roots. Let's go over some definitions first. Perfect cube, a number whose cube is a whole number. So for example, 2 cubed, that equals 8, because 2 times 2 times 2 is 8. So 8 is what we would call a perfect cubed. A cube root, that's a number that when multiplied by itself and then multiplied by itself again equals the same number under the cube root symbol. And this is our cube root symbol. Alright, so for example, the cube root of 8 equals 2, since we know that 2 times 2 times 2 is 8. So it goes back and forth. Fig number 1, you can use perfect cubes to estimate non-perfect cubes. So let's go over some examples, okay? 4 cubed. So think about that. 4 cubed is 4 times 4, which is 16, times 4 is 64. So 4 cubed equals 16. 7 cubed. That's, remember, 7 times 7 times 7. When you multiply that out, that equals 343. A famous one that you'll be seeing a lot is 5 cubed. Remember, 5 cubed is 5 times 5 times 5. So we know that that equals 125. All right. Let's look at this example. This is a cube root of negative 1,728. That equals negative 12. So when we look at it, we know that negative 12 times negative 12 is positive 144 times negative 12. Okay. Example number 5. The cube root of 729. Well, that's 9 times 9 times 9, so I know that that is 9. So the cube root of 64 equals 4 times 4 times 4, so I know the answer to that is 4. All right, so Vic number 2. Notice, unlike square roots, that these cube roots always have one answer. And that answer can either be positive or negative. And remember, the integer rule for multiplication is that a negative times a negative is a positive. So when you do have square roots, your outcome would be positive. But with cube roots, you have that odd number hanging out there, so the outcome could either be positive or negative. Let's talk about estimating some cube roots. Not all cube roots are perfect cubes. In these cases, you can use what you know about cube roots to estimate what the cube root of a non-perfect cube would be. Okay? So let's look at some examples. So let's determine which 2 integers each cube root would fall between. So number 1, when you look at the cube root of 56, okay, I know the perfect cube 3 is the cube root of 27. Then I know that, and that comes before the cube root of 56. Well, then to get an integer after that, to have consecutive integers, that the cube root of 64, which is 4. So I know that looking at these 2 integers, that the cube root of 56 falls between 3 and 4. Okay? Let's look at the cube root of negative 389. Again, this is negative, so we have to reverse our thought process. So the cube root of negative 512 comes before the cube root of negative 389. And so then the one that would come after that would be the cube root of negative 343. And we would see that that is definitely negative 8. And we would know that if we did the math at negative 7, it would be the cube root of negative 343. So we can see that it is clearly between negative 8 and negative 7. So let's look at the cube root of 182. Let's work this one together. All right. So one before would be the cube root of 125, which is 5. So 5 times 5 times 5 is 125. And then the one after this would be the cube root of 216. And so that perfect cube would be 6. All right, so we know it's definitely falling in between those two. So it's between 5 and 6. When I look at it on the number line, it would be located between those two.